Following from the yesterday's class, we are continuing Irula problems again. Right. Look at 3.105. Find the capacitance of a spherical capacitor whose electrodes have radii R1 and R2 with R2 greater than R1 and filled with some material whose permittivity at epsilon R kaadu, permittivity, not other. You can convert it like this: dielectric constant varies as A epsilon naught by R. Likewise, it is up to you. Right. I think none no. Okay. Pattern vinnava, lesson vinnava. అదానికి దీనికి సంబంధమే ఉంది. Right. Now you see, in this, find the capacitance of a spherical capacitor whose electrodes have radii R1 and R2 greater than R1, which you can see that filled with isotropic dielectric aitena, all our rules come true. Otherwise, you cannot. Where A is a constant and R is the distance from the center of the capacitor. Right. Now the question is, now we are assuming that this is R1. This is R. R1, R2. R2 greater than R1, taken care. Now, what do you want? Capacitance of the spherical capacitor. See, try to please understand, if suppose there is nothing, my general formula is C is equal to 4 pi epsilon naught 1 by A minus 1 by B. Do you remember this last week topic? Now you imagine now you imagine this one is of radius R and this one is of radius dr. And you have filled something in this. Here it is of course some dielectric material. Now only this capacity, can you please help me in writing this? Only that part capacity. 4 pi. Is it epsilon naught or epsilon? You should write epsilon at that point. Epsilon 1 by R minus 1 by R plus dr. You know, you will get this as 4 pi A by R dr by nearly R square. R plus dr into R is nearly R square. So therefore, this you can write it as finally dc is equal to 4 pi A R by dr. What is this, by the way? capacitance of an elemental shell. Likewise, you will have shells from. Likewise, you will have shells from. Tell me from where to where. Small r is equal to capital R1 to small r is equal to capital R2. Can you please help me? How are they? Are they in series or parallel? Series. Sir, how do I know it is in series? Remember, it is the same charge that passed through all these layers. If the same charge is passing through all the capacitors, what nature of connection is that? Series. Therefore, 1 by dc is equal to dr by 4 pi ar 1 by 4 pi a log e r2 by r1. Agreed? You know this integration, right? Integral 1 by r dr is logarithm. Ariyar, why you are seeing like a surprise face on to me? 1 by r dr r1 to r2 can be written as log e r2 by r1. That's what. By the way, what is your question? Don't forget that. What is the capacity? In fact, this is a C effect. So the effective capacitance of this arrangement is 4 pi a by log e r2 by r1. Four pi a by log e r2 by r1. Any doubts? Boys and girls? Pakka? Sure? Tell me yes or no. Clear? Right. Very good question. So today, at least whatever the notes that I am posting today, at least none of you have taken printout anyway, right? I think. Now I will add some more questions again. I have added all difficult questions. I failed to add previous IIT questions in this. I will now add previous IIT questions also in this file. So that the other day, when you take an entire dielectric, that is a single book that answers everything. All right. May I proceed for the next question? Everyone in the class? Right. Now consider the situation shown in this figure. This is the figure. Consider the situation shown in this figure. Again, HC Burma question. Okay, you have a width of the each plate is B. The capacitor plates are rigidly clamped in the laboratory. All that is fine. Arya, yesterday only I taught this. What is the formula for the force? Can you please tell me? What is the formula for force? 1 minute, 1 minute, 1 minute. Now tell me what is the formula for the force acting on a dielectric slab? Yesterday I have given. F is equal to V square by 2 epsilon naught area by length into distance times k minus 1, dielectric constant minus 1. See, in HC Verma book, they will use K. In Irido, they will use epsilon. So don't get confused. Remember, what is the nature of this force? The nature of this force is attractive. Tension force. Tension force, mg. So what is the condition for equilibrium? This should be equal to T. What else you want? That's it. That is equal to mg. So calculate the value of m. So therefore, m is nothing but v square epsilon naught L into B times K minus 1 by 2 LDG. L cancel. So finally, M is epsilon naught V square B K minus 1 by 2 dg. Any doubt in this question? Please ask. Pakka? Easy only now? Right. Actually, I will enjoy questions from Irido, Pathfinder, teaching. Even though I teach only 3 or 4 questions, no, the depth of content will be high in those questions, actually. Learning 3 such questions is equal to practicing 10 such questions. Right. Next question. Before this question, I require some basic theory again to be taught to you. For example, you have cylindrical capacitor. The cylindrical capacitor is like this for you. Imagine an infinite cylindrical capacitor. So I'm showing you a very finite portion. Infinite. So at any point which is at a distance r, you know the expression for intensity of the electric field. So if you imagine the total charge per unit surface area on this is a sigma, then E into 2 pi r L is 1 by sigma naught, epsilon naught, sigma, sigma charge enclosed. Charge enclosed on this portion. And that you will write it as sigma 2 pi capital R L. So therefore, E is sigma R by 2 pi epsilon naught R. You can write this as lambda. Lambda by 2 pi epsilon naught R. You can write it as charge per unit length. From this, you will get capacitance also. For a cylindrical capacitor, you can obtain, for a cylindrical capacitor, you can obtain capacitance also in the same way. Right. How? You know already, you will find potential difference and thereby you will get capacitance. Right. This is about a cylindrical capacitor E formula. E. Lambda stands for charge per unit length. Right. Now the question is, now you take a cylindrical capacitor, cylindrical a conductor otherwise. Now this is a cylindrical conductor whose radius now I require, 1 minute. I require some arrangement, neat arrangement. In this, What is that you are seeing outside world is a medium of permittivity epsilon or dielectric constant K. Now, what is that you are seeing is a cylindrical conductor which is having some charge. A cylindrical conductor which is having some charge. And this is some point P, which is at a distance R. Okay. At P, the intensity of electric field is given by lambda by 2 pi epsilon R, not epsilon not R. This is the net intensity of the electric field at the point P. Right. This is for a cylindrical conductor. Even for spherical conductor also, you will have the same situation. Okay. Now, again, what is a dielectric strength? Anytime when you are questioned about a dielectric strength, you should say dielectric strength is that intensity. I taught this actually. It is that intensity of electric field where the material will not behave as a dielectric. It will become, the bonds will break. The molecule actually right now is stretched. The positive charge is stretched in one direction, negative charge center is stretched in the other direction, and they were separated, giving rise to some intrinsic dipole moment. Wrong. Now, when the field is strong, what happens? They will break. They will become free charges. And it is no longer a dielectric. It will become a conductor. So, such a field, the minimum field when such situation happens is called dielectrics breakdown or dielectric strength of the material. Right. Hold on. Now the question is, now this is your question right now. A cylindrical capacitor is filled with two cylindrical layers of dielectric with permittivities epsilon 1 and epsilon 2. There are two layers, epsilon 1 and epsilon 2. The inside radii of the layers are equal to R1 and R2 with R2 greater than R1. Stop. Give me some time to draw this. You can see three regions. Remember, whatever that you are seeing over here, whatever that you are seeing over here, that green portion is what we will call as the conductor and surrounded by a medium whose dielectric constant is epsilon 1, the other medium whose dielectric constant is epsilon 2. Now, see, try to understand. I will choose one point over here, one, another point over here, two, deep inside. Now, at one, can you please help me in understanding what is E1? E1 is, just now I have given you formula, lambda by 2 pi epsilon r. In this case, E1 becomes lambda by 2 pi epsilon 1 r. E2 becomes lambda by 2 pi epsilon 2 r. Any doubt? Now, try to please understand, in this case, this is R1 less than R less than R2. And this is R2 less than R, say less than R3, assuming that the boundaries are till R3. Medium 1 range is between R1 to R2. Medium 2 range is between R2 to R3. And where the field is strong in the region R1 to R2 as per the formula. Where the field is strong in the region between R1 and R2. R1, R2 in between, where the field will be strong. Obviously at R1. If it is condition of breakdown, it happens at R is equal to R1. Thereafter, what happens? That is a different story. So therefore, E1 max is lambda by 2 pi epsilon 1 R1. I got the condition. Same question in this region. If it is condition of breakdown, it happens at R is equal to R2. What do you want? Question. Go to the question now. So you want a situation or a relationship where breakdown value has to happen in both the dielectrics simultaneously. Right? If my lambda is selected, if lambda is selected such that if lambda is selected such that 1 and 2 happens at a time. By the way, lambda stands for charge per unit length on the conductor. It is common for both the regions. So therefore, E1m epsilon 1 R1 is equal to E2m epsilon 2 R2 is equal to lambda by 2 pi. This is the condition. If this condition is satisfied, breakdown happens in both the region at a time. Such a lambda you need to pick. If your lambda is equal to 2 pi E1m epsilon 1 capital R or E2m epsilon 2 capital R2, this is possible. You should pick such a one. Any doubts? This is a very famous question. If you have any doubt, don't hesitate. Please ask me right now. Do you have any doubt on this? Boys and girls. Follow in a turn on the go. Zanga follow in. What about you? There is no replication from your face. What is that troubling you on the board right now? Take your own time. No issues. What is troubling you on the board? This is your next question. Read this carefully. There is a double layer cylindrical capacitor whose parameters are as shown in the figure. Fine. Okay. The breakdown field strength values for these dielectric. What was E1M and E2M in the previous question are now E1 and E2 in this question. Here, please don't get confused. What was E1M and E2M in the previous question are E1 and E2 right now. Remember, E1 and E2 are not electric field straight away. They are breakdown or what you call dielectric strengths. Right. So what is the breakdown voltage of this capacitor if this one is taken as a condition? All of a sudden, I have a different situation. All of a sudden, I have a different situation. I'll explain this in my style. Epsilon 1, E1, R1, lambda by 2 pi. Agreed? Just you accept. If this condition exists, remember what is this condition? This is the condition for breakdown in R1 less than R less than R2. Agreed? I am honestly asking again. Sure? No. Don't get confused. What was E1M in the previous question is now E1 in this question. E2 epsilon 2 R2 is some lambda dash by 2 pi is the condition for breakdown in R2 less than R less than R3. Agreed? Now from the question, what is the condition given? Lambda is less than lambda dash. Lambda, whatever the charge per unit length right now is less than lambda dash. Okay, what is the meaning of this? If I pick lambda as the charge, lambda less than lambda dash means if I pick lambda as my charge per unit length, what happens? Breakdown will happen in which part first? Lambda less than lambda dash. You can't make lambda is equal to lambda dash. If here lambda less than lambda dash means, suppose I'm increasing lambda. For example, lambda is 3, lambda dash is 4, for example. Now you will increase the charge on the cylinder 0 to 1 first. No issues. Nowhere there is breakdown. 1 to 2. Nowhere there is breakdown. 2 to 3. What happens first? Breakdown happens first at R1 less than R2 region. But still R2 less than R3 region is safe. So first breakdown happens in which region? R1 less than R2. So you said lambda is less than lambda dash. You will increase from 0 to higher values. So therefore, the meaning of this statement is clearly breakdown happens in region 1 before region 2. I am asking you again. This is the heart part of my question. Are you convinced with that or you want much more explanation of that? అర్థమైందా? What about you? What about you? Srinidhi, Renora, what about you? Whatever the question, they have given this condition. Previously, I have derived this is the condition. This is the condition. If I choose such an epsilon 1, such an epsilon 2, one lambda is sufficient. For a given lambda, both simultaneously happen. But you have given a different condition here. So with this, I am assuming charge here is different, charge here is different. For example, from the given condition, what is that you are expressing is lambda is less than lambda dash. So which means as I increase lambda from 0 to higher values, where the breakdown starts first? In the R1 less than R2 region. Thereafter, nothing. You should avoid breakdown in any region. That's the question. What is the breakdown voltage of this capacitor? So once if lambda is reached, breakdown takes place. Before reaching lambda dash, you have nothing to left in this region. So therefore, from this I can conclude that now we will assume, hold on. Now we will assume, so I want a lambda situation, not lambda dash situation. Fine, no issues. Now, for example, I am changing my notation. Let E1 dash be intensity of electric field. Say for example, means I am not considering the case at the breakdown. So obviously, even in E2 also there won't be any breakdown. If it happens breakdown, it has to happen first at R1 less than R2 region. So I am choosing my E in the region 1 lesser than that breakdown condition. Then what is the expression for potential difference? Simply E1 dash dr plus E2 dash dr R2 to R3 R1 to R2. E1 dash, boys, E1 dash. What is E1 dash? I have given already formulas previously only. Lambda by 2 pi. So therefore, this is lambda by 2 pi epsilon 1 r dr. So R1 R2 plus R1 R2 lambda by 2 pi epsilon 2 r dr R2 R3. By the way, this will become lambda by 2 pi epsilon 1 log E R2 by R1 plus lambda by 2 pi epsilon 2 log E R3 by R2. By the way, boys and girls, lambda by 2 pi, now I will take it as E1 epsilon 1 R1. But don't look at me. That's what you want. Now, therefore, this can further be written as lambda by 2 pi epsilon 1 can be written as E1 R1 log E R2 by R1. Lambda by 2 pi can be written as E1 R1 epsilon 1 by epsilon 2 log E R3 by R2. Therefore, I will conclude the potential difference for breakdown is E1 R1. If you take a common, it will become log E R2 by R1 plus epsilon 2 by, epsilon 1 by epsilon 2 times log E R3 by R2. Any doubt in that? You are finding bit difficult in seeing that. Okay, I've understood. I will write everything over here. Why should I save the space? This can be written as even R1 common log E R2 by R1 plus epsilon 1 by epsilon 2 log E R3 by R2. This is the potential difference at breakdown region. If you avoid this much potential difference, there is no breakdown. If you reach this potential difference, what will happen? Breakdown will first happen at R1 less at the point R2. Right or not? Okay. Any doubt in this? Clear? Pakka? Right. May I proceed for the next question? Didi, there is no here. You have Sunday tomorrow. I'll post these notes. Take a print of this. I am not suggesting you on maintaining the notes. You have these notes. Both capacitor and dielectric, you show me on Monday. Okay? Right? Next. Yes. 3.86. 3.86 diagram is missing. 3.86 diagram is missing. I'll draw the diagram. Same question is there in pathway. And I'll discuss that question also later. Half the space between the two concentric electrodes of a spherical capacitor is filled as shown. Okay, that is the space filled with dielectric of permittivity epsilon. Right. The charge of the capacitor is Q. Find the magnitude of the electric field strength between the electrodes as a function of distance R from the curvature center of the electrodes. Right. Remember, first observation here is, I told you very clearly, potential difference is the same. Whether you choose in this region or choose in this region, intensity of the electric field is the same. Already I have shown that. Very first class. In this, in these two parallel plates, since the potential drop across these two plates is the same, whether you choose a point here or choose a point here, potential difference is the same. Intensity of electric field is the same. What makes the difference is accumulation of charge over here and accumulation of charge over here is different. That's the reason why I have shown you as Q1 and Q2. Okay? Same logic you require there. Same logic you require there. Now we assume difficult, I know. Right. I have tried here. We meet. It's our notes after all. Now, yeah. Now, this portion which you are taking is of radius r and thickness is dr. Now, you simply apply Gauss law. Apply Gauss law. You should apply Gauss law as two different parts. Why? Can someone please explain why I should apply as two parts? In this, the lower half is in dielectric portion. The upper half is in air portion. So for Gauss law in dielectrics, what is the condition? Epsilon K, dielectric constant, K into E into dr plus 1 into E into dr is 1 by epsilon naught times Q free charge. Do you remember this relation? Don't get confused. You are looking at me, why you are writing two terms? Because half is in dielectric, half is in air. In air, Gauss law form you know already right now. In dielectric, this is the form of the Gauss law. This is how you will have Gauss law. Now what is happening over here? K times E into 2 pi r square plus E into 2 pi r square is equal to 1 by epsilon naught cube. 2 pi epsilon naught times 1 by k plus 1 times 1 by r square. So the intensity of the electric field is like this. But please note here, charge distribution in lower half is different from upper half. I'm asking you again, have you followed this question? Yes or no? You have almost the same question in Pathfinder. This is the question. Can you try this? Radii of the inner and outer conducting spherical shells. Same question, boss. Same question. Find the expression for electric field in both the dielectrics and potential difference between the spheres. Same question. Even if required, I will extend the question also in the same. Now, I'll apply Gauss law again. Apply Gauss law. By applying Gauss law properly, you will have epsilon 1 E ds plus epsilon 2 E ds is Q free, which is nothing but Q. Q free, Q bound. I have used two different Qs. Don't forget. When Q bound comes, polarization vector comes in the picture. Gauss law. When Q free comes, KE comes in the picture. Right. Next. So this can be written as E1 E2 pi R square plus E2 E2 pi R square is equal to Q. So therefore, E is Q by 2 pi R square times 1 by epsilon 1 plus 1 by epsilon 2. Right. Okay. And not only that, the capacitance of the upper half is, capacitance of the upper half is 2 pi epsilon 1, 1 by A minus 1 by B. Why 2 pi? Usually the formula is 4 pi epsilon naught by 1 by A. It's only half the part you are taking. C2 is 2 pi epsilon 2 by 1 by A minus 1 by B. How are they? The combination of capacitance, how are they? Parallel, absolutely correct. So C effective is 2 pi times 1 by A minus 1 by B times epsilon 1 plus epsilon 2. So who asked you this? Hey, don't worry, I'll answer this. Potential difference is Q by C effective. You want potential difference also, no? So therefore, Q by 2 pi times 1 by A minus 1 by B times epsilon 1 plus epsilon 2. So therefore, this is Q times B minus A by 2 pi AB times epsilon 1 plus epsilon 2. Not only that, I can give you the charges distributed also. Like for example, if the distribution of charge in this part is Q1, if the distribution of charge in the lower half is Q2, that also I can give. How? Simple. Q1 is C1 delta V. So therefore, it is 2 pi epsilon 1 AB by B minus A times Q into B minus A by 2 pi AB epsilon 1 plus epsilon 2. Cancel, 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 cancel. Finally, I can write it as epsilon 1 by epsilon 1 plus epsilon 2 Q. This is a Q1. Similarly, I can write Q2 as epsilon 2 by epsilon 1 plus epsilon 2 times Q. A very good model. But still, I'm asking you, do you have any doubt on this? Please ask. Both are same questions. Both are same questions. Now, what is happening? Suppose I talk the first one, and this is appearing in the exam, you are failing. Why you are failing? You are failing in taking the core concept inside. You are seeing numbers, even epsilon 1. Only that letters you are finding on the board. But nothing is going in as a concept. Same concept I have used actually here. Please see. Any doubts still further? Boys and girls. Pakka? May I proceed for the next question? Boys and girls, may I proceed for the next question? Right. And this is one such question from Pathfinder again. Good question. Go ahead. Parallel plate capacitor of capacitance. Parallel plate capacitor of capacitance C naught is charged to a voltage V. And then battery is disconnected. A dielectric covering 1/3 area of each plate is now inserted as shown in the figure. The charges on the capacitor plates are redistributed such that the portions covered with the dielectric and not covered with the dielectric share equal amounts of. This is two different data involved in the question. Two different data. Dielectric constant of the dielectric is 2. So that I need to find that first. I am finding out this as a circuit. As per my understanding, if you permit me, I will try to understand this circuit as. That is the circuit. Initially, this is the circuit without capacity. So initially, the energy stored is half C naught V square. In such an arrangement, this is a C naught by 3, this is a C naught by 3, this is a C naught by 3. This is without dielectric. And you remove the battery now. As it is, situation is this. Actually, here charge is a constant. The total charge in the system is C naught V, and this is constant actually. Right. Now, what happens thereafter is this will become Kc naught by 3, and they are still C naught by 3, C naught by 3. What is your question, by the way? Dielectric, if the charges on the capacitor gets redistributed such that the portion covered with the dielectric and not covered with the dielectric share the equal amount. I am assuming this has charge Q1, this has charge Q2, this has charge Q3. If you permit me, I will write Q1 is to Q2 is to Q3 is for parallel combination, Q is equal to CV, V is a constant, parallel combination. Q1 is to Q2 is to Q3 is C1 is to C2 is to C3. So therefore, K C naught by 3 is to C naught by 3 is to C naught by 3. So therefore, Q1 is to Q2 is to Q3 is nothing but K is to 1 is to 1. So you need to break the total charge Q into 3 parts. Bearing ratio K is to 1 is to 1. So obviously Q1 will be equal to K by K plus 2 times of Q. Ratio distribution here. And Q2 is equal to 1 by K plus 2 times Q. Q3 is equal to 1 by K plus 2 times Q. Now, K by K plus 2 times Q is given as Q2 plus Q3. That's given in the question, which means 2 by K plus 2 times Q. By cancelling, you will get the dielectric constant as. Agreed till this point, boys and girls? Right. So therefore, first option is correct. Charge appearing due to polarization on the surface of the dielectric. Hold on. First, what is Q1? Q1 now can be written as this numerator is 2, numerator is 2, denominator is 4. So therefore Q1 is Q by 2. But that is not the question. Now you focus here. Now this is plus Q1. This is a minus Q1. So what is going to be the charge on here? Minus Q1 times 1 minus 1 by K. This is nothing but minus Q by 2 times 1 minus 1 by 2, which is nothing but minus Q by 4. So at this point, the charge is plus Q by 4. Plus Q by 4 is nothing but C naught V by 4. Agreed? Agreed? Array, any doubts? అర్థమైందా? ఎక్కడ తేడా కొట్టింది? ఎక్కడ కొట్టింది? ఈ రేషియోలో. అదే నాన్న ఎక్కడ ఎలా వచ్చిందంట? అరే టోటల్ క్వాంటిటీ క్యూని K:1:1 డిస్ట్రిబ్యూషన్ ఎట్లా జరుగుతుంది? ఒకసారి మళ్ళీ అడుగు, నీ క్వశ్చన్ అడుగు, నాకు క్లారిటీ. K:1:1 దాకా అర్థమైందా? అర్థమైంది. టోటల్ క్వాంటిటీ ఏం కావాలి? Q1 ప్లస్, డోంట్ ఫర్గెట్, Q1 ప్లస్ Q2 ప్లస్ Q3 ఈజ్ Q ఆల్రెడీ, యు నో దట్ ఈస్ C నాట్ V. బ్యాటరీ డిస్కనెక్షన్ చేసేసాక ఛార్జ్ ఈస్ కాన్స్టెంట్. టోటల్ C నాట్ Vని K:1:1 ఎలా డిస్ట్రిబ్యూట్ చేస్తాం? ఒకటి K పార్ట్స్ డిస్ట్రిబ్యూట్ చేయాలి, ఒకటి 1 పార్ట్ డిస్ట్రిబ్యూట్ చేయాలి, ఇంకోటి 1 పార్ట్ డిస్ట్రిబ్యూట్ చేయాలి. ఎట్లా డిస్ట్రిబ్యూట్ చేస్తాం? అంతే కదా, అప్పుడు ఇలానే కదా నువ్వు చేయాల్సిందే. 2:1:1 వచ్చింది, ఎలా డిస్ట్రిబ్యూట్ చేస్తావు? ఒకటికి 2 ఇవ్వం. టోటల్ని 2+1+1 చేసేసి 2 by టోటల్ పార్ట్ ఆఫ్ ద టోటల్ క్వాంటిటీ ఒకటికి వెళ్తుంది. నీకు మ్యాథ్స్ రాలా అక్కడ, అది ప్రాబ్లం. If a quantity is distributed, if a quantity P is distributed as X is to Y is to Z, then this person will get X by X plus Y plus Z times P. This person will get Y by X plus Y plus Z times P. And the other person will get Z by X plus Y plus Z times P. That is mathematics. Okay? Apart from that, you have any doubt? ఇంకేముంటుంది అక్కడి నుంచి? ఈ రెండు సేమ్ అన్నావు. Q2 ప్లస్ Q3 ఏదో ఎంత ఉంటుందో Q1 అంత ఉంటుంది అని చెప్పా ఒక సెంటర్. దాని నుంచి K by K plus 2 times Q is equal to 2 by K plus 2 times Q. So K got 2. ఓకే, నెక్స్ట్ ఇంకో మాట. ఇక్కడ ఇండ్యూస్డ్ ఛార్జెస్ ఎంత అని అడిగారు. లాస్ట్ 3 days నుంచి వీళ్ళకి చెప్తున్నా, ప్లేట్ మీద Q చార్జ్ ఉంటే డైఎలక్ట్రిక్ మీద ఎంత ఉంటుంది అంటే చార్జ్ -Q ఇంటూ 1 - 1 by K. అది డెరైవ్ కూడా చేశాను నేను. అందుకే నేను రాగానే ఫస్ట్ 2-3 క్లాసెస్ వీడియోస్ ఉన్నావా లేదా అని అడిగింది. రైట్, దట్ ఈస్ ద కేస్. That is not the completion of the question. One more part is also there. Now, I am asking you, first part of the question is done. Second part, charge appearing due to polarization is also correct. This is also correct. Next, CD options are there. That also we need to work. What is the other part? Force of electrostatic interaction between portions of the plates covered with the dielectric is equal to force uncovered portions. Actually, last, if a capacitor topic is done, what is the formula for force? Force formula is if the plates are having charge plus Q and a minus Q, okay, they will experience an attractive force. The expression for such a force is Q square by 2A epsilon naught. Okay, now here on the first capacitor, the charge, I think now you got the point. The charge here is Q by 2, Q by 2, right? So, the force between the plates, the force initially is this much. Later on, the force now this is plate A by 3 and this is of the plate 2A by 3. When I am writing this condition, after inserting dielectric, when is this condition used? Before inserting dielectric. Now you calculate the force. This is F1 and this is F2. So F1 plus F2 is Q square by 4 by 2 times A by 3 epsilon naught plus Q square by 4 by 2 times 2A by 3 epsilon naught. So here you are getting Q square by 4, 3Q square by 4A common, 4A nahi, 8A common. What is the balance? 1 plus 1 plus 1 by 2. This is what you will get? 9 by 2 times Q square by 8A. Just please confirm whether my calculation is correct or not. Just please confirm this. F1 plus F2, Q square by 4, 2A by 3 epsilon plus Q square by 4 by 2 into 2. Right. Now, please confirm whether you have properly followed this or not. Now, this will become Q square by 2A epsilon naught, you take common. 3 by 4 plus 3 by 8. Q square by 2 if F final. So F final is F initial times 9 by 8. That is the deal. Any doubt in this? Boys and girls? Previously, do you know this? ఇనికి ఈ రిలేషన్ తెలుసా ఇది? అరే లాస్ట్ వీక్ టాపిక్ ఇది. Force between two parallel plates with air. This is the force between the same two parallel plates with partially filled with dielectric. So it is 9 by 8 times the previousness. It's more. So what was given? Force of electrostatic interreaction between portions of the plates covered with the dielectric wrong. It's not equal. Next. 9 by 8 times is correct. Right. Very good question. Really very good question. Next question. Again, it is from Pathfinder. We will do easy questions first. 3.1442. Go through this question carefully. Parallel plate capacitor is located. A parallel plate capacitor is located horizontally so that one of the plates is submerged into the liquid while the other is covered with the surface. Permittivity of the liquid is equal to epsilon, density is equal to rho. To what height will the level of the liquid in the capacitor rise? So now my point is the final diagram, I am assuming the final part of the diagram, I am assuming it like this. So I am assuming at a given instant, this is the height. And remember, all this is dielectric part. All this part is dielectric. And this is d minus h. Air. Remember, you are applying potential difference across the plates. Across the plates. Remember, you are giving charge to the plates. Don't forget that. Because that you have given charge to the plates, you have seen from rise. Now, at a given instant, what is the total energy? The total energy is electrostatic plus gravitational potential energy. What is electrostatic potential energy? Half. And you know, if you ask me the charge of a capacitor, you will simply write as Q square by 2C. Another way is also there writing. Q is sigma A. Charge is sigma A. You can write this as sigma square A square by 2 epsilon naught A by D. This can be written as sigma square AD. AD refers to volume by 2 epsilon. Whether you know this in the previous week or not, I don't care, but I have given this right now. At least please say yes or no for this. Sorry, no adagara, nikedo doubt unda kada. Clear? Q square by 2C energy అని తెలుసు కదా. దాని నుంచి సిగ్మా టర్మ్స్ లో రాసుకోవటం తెలిసింది కదా. Sigma is the charge on the plate, metal plate. By the way, U is again two parts, air part, dielectric part. What is in the air part? Sigma square A by epsilon naught into D minus H. This is the air part. Plus dielectric part, half epsilon square A by epsilon relative అరే వాడు ఎప్సిలాన్ ఇచ్చేసాడు, మనం కాసేపు ఎప్సిలాన్ ఆర్ ఎప్సిలాన్ నాట్, వేర్ ఎప్సిలాన్ ఈజ్ ఎప్సిలాన్ ఆర్ ఎప్సిలాన్ నాట్, because the difference between irido and pathfinder, irido and HC1. And this part will be A into H, right? Plus potential energy. See, if it is mgh by 2 as the potential energy, mass can be written as area, height, density, g, h by 2. Yes or no? Just please confirm that. అరే మాస్ అంటే ఏంట్రా అది? ఏరియా, హైట్, వాల్యూమ్ ఇంటూ డెన్సిటీ, మాస్, gh by 2. So therefore, this you can write as A rho g h square by 2. Now, U is clearly a function of h. Any system which is in equilibrium, any system which is in equilibrium, any system which is in equilibrium will try to possess minimum potential energy. Yes or no? That we know fundamentally. So therefore, du by dh 0 gives a h where u is minimum, which means sigma square a by 2 epsilon naught 0 minus 1 plus sigma square a by 2 epsilon r epsilon naught 1 plus a rho g h is equal to 0. We are taking, say, some h dash. This is happening. This is 0 at a specific h dash. So now I rewrite this properly as h dash is equal to, by the way, you cancel a everywhere, sigma square by 2 rho g epsilon naught. If you take common, you will get situation as 1 minus 1 by epsilon r, right? At this h dash, potential energy is minimum. They are also asking you to what height will the level of the liquid rise after this plate gets a charge of surface density. It's a very simple solution. In Irido, in HC Verma, they have given completely different solution. That also I will show you right now. There is a mistake as per my observation in that. I'll just show you that. Both are volume 1 and volume 2. Right now. I just have. Now you see in HC Verma, the solution which they have given, just see this. To show you. Same question. Parallel plate capacitor is placed in such a way that its plates are horizontal and the lower plate is dipped. Okay, everything is fine. So they have done this in force method. Remember, different forces are involved here. When I do force method, I won't get before it reaches net force 0. What if the liquid layer is moving up? What has he done is, he have done in the force method. So the net force holding this part, balancing the other forces. Likewise, HC Verma sir have done this in force method. Somehow this is not correct because Irido is an old book when compared to SC1. The first print was given in the year 1971. So 1971 in India. Earlier when it happened, I have no idea. Therefore, at least this is some 50 years old book. We should respect that. So therefore, in this I am following Irido method. Okay? Got the point? Right. I'll deal one more question maximum. Right. Very good question. This one. Excellent question. Remember, other chapters, you have an opportunity, other chapters. See, remember, this question you could do only when you know this relation. Only when you know that relation. If you don't know that relation, you cannot solve that question. Next. A cylindrical layer of dielectric, please go through this. This will be the last question. This will be the last question for the day. And tomorrow, no, not tomorrow, day after tomorrow, I'll deal previous IIT questions. And the last class, I will deal higher order models related to Pathfinder. If you have this content with you, you can solve maximum models. A cylindrical layer of dielectric with permittivity epsilon is inserted into a cylindrical capacitor to fill up all the space between the electrodes. Right. Already we know the capacitance. The capacitance per unit length. The capacitance per unit length of a cylindrical capacitor is 2 pi epsilon naught by log E R2 by R1. This is the general formula. Here, R2 term is nothing but R plus D. R1 term is nothing but R. Now, please answer me carefully. Have you followed till this point? Please go through question. I didn't started the question. Whatever the elements required to solve this question, I just posted. Are we clear till this point? Here, there is a term. Yes. The cylindrical layer of dielectric with permittivity epsilon is conducted. The mean radius of the electrodes, mean radius, yeah, almost you can consider like that. No issues. Almost you can consider like that. So, no, 1 minute is very clear. R2 by R1 is the general formula, which means, hold on. If you see from top, this is R1, this is R2. If this is the case, you are using this formula. Now the question is, after a smart modification, a cylindrical layer of dielectric with permitted, right? The mean radius of the dielectric, right? Now this is from the top view. Actually, from side view, what is happening, you know? This is side view. That is your cylinder. You have filled it like this. The dielectric, say, filled it up to a height of y. Air is between, total height is h minus y. Side view, top view. In this case, mean radius of the electrodes is equal to r, means r1 plus r2 by 2 is r. The issue is R1 plus R2 can be written as R1 plus D by 2 is equal to R. So R1 plus D by 2 is equal to R. I think you followed my question. So therefore, R2 is simply R2 is 2R minus R1. 2R minus R minus D by 2, which is R minus D by 2. R1 is R, 1 minute, I think I have done some mistake, plus D by 2. So R1 is R minus D by 2. Now why all this nonsense you are doing? Means this capacitance 2 pi epsilon naught by log E R2 by R1 can be written as 2 pi epsilon naught by log E R plus D by 2 by R minus D by 2. This can be written as 2 pi epsilon naught by log M by log N can be written as log M minus N. Agreed? Log E R plus D by 2 minus log E R minus D by 2. Likewise. You can take something as this, you can write it as 2 pi epsilon naught log E 1 plus D by 2R minus log E 1 minus D by 2R. You can take it like this, because the log R terms will get cancelled. So finally, earlier when T is much smaller than R, log E 1 plus D by 2R is nearly D by 2R. This you need to know. Log E 1 minus D by 2R is nearly minus D by 2R. You can take it, expansions. So finally, this can be written as 2 pi epsilon naught by D by R. Hare Naina, this is the question. I have nothing to do with this data till now. The only thing you need to know in this question, in this case, capacitance is 2 pi epsilon naught R by D. At least you can notice this. This is one way, foolish way of solving things. Easy way of solving things is when the distance is very close, cylindrical capacitor becomes parallel plate capacitor, which means C is epsilon naught A by D. Epsilon naught. What is area here? 2 pi R L by D. C by L is called capacitance per unit length. In fact, I have given you capacitance per unit length only, which is nothing but 2 pi epsilon naught R by D. Now you see, I got the same relation. Instead of foolish way of deriving this much, if you could assume it like a parallel plate capacitor, it is like 2 pi epsilon naught R by D is the capacitance per unit length. This is also capacitance per unit length. This is also capacitance per unit length. Okay, now ignore all. 2 pi epsilon naught R by D is the capacitance per unit length. By the way, what do you want? What is the total capacitance of the arrangement? This is C air plus C dielectric. C air 2 pi epsilon naught R by D times H minus Y, because that is the air part. Next part is 2 pi epsilon R epsilon naught by D times R into Y. Agreed? So what is the expression for capacitance? 2 pi epsilon naught R by D common. You will get epsilon R minus 1 Y plus H. Remember, that is the capacitance, not capacitance per unit length, because followed by some multiplication factor of the length term. By the way, what I want again? See here, battery is fixed. Battery is fixed. Constant potential difference. So what is the expression for energy in constant potential? Half CV square. Now what is the force? Minus du by dy. Same, because it is a conservative. So here it is nothing but minus v square by 2 times dc by dy. So therefore this will become 2 pi epsilon naught r v square. You can see. No. Everything will spoil now. Right. 2 pi epsilon r v square by d times epsilon r minus 1. That is the picture. Right. What is that they are asking is find the magnitude of the electric force pulling that. Only one statement. Almost reached.